According to the United States Postal Service website, pieces going to a domestic location may not measure more than 108 inches in length and girth combined. Under this restriction, what is the largest rectangular parcel you could ship to a domestic address in the United States? The longest dimension of any parcel is always considered the length, and the girth is the distance around the remaining two dimensions, or the perimeter of a cross-section of the length. So the girth of a rectangular solid is twice the height plus twice the width. The post office requires that the length plus the girth be at most 108 inches. That means the box with the biggest volume would be one whose length and girth are equal to 108 inches. To mail such a box, we would need to know which dimensions achieve that maximum volume. We want to get the most area out of any given cross-section. The rectangle with the biggest area for a given perimeter is a square. So let's assume the cross-section to be a perfect square, with all four sides equal. Then the girth will be 4 times the width. So the length, which is L, plus the girth, 4W, is equal to 108. If we solve for L, we get the length in terms of the width. Now the volume for any rectangular solid is the product of all three dimensions, length times width times height. Remember, since this cross-section is a perfect square, the height is equal to the width. So the volume of this box is length times width squared. Since we know the length in terms of the width, we can plug that in for L. And now let's go ahead and distribute the W squared. If we graph this function, the horizontal axis would represent the width of the box, and the vertical axis would be its volume. What we have is a cubic function. The leading term is negative, and with a double root at 0, the function might look something like this. We want to maximize the volume of this box. In other words, we want to find the point on this function where the volume reaches a maximum value. The tangent line at any such point will always be horizontal, with a slope of 0. Therefore, if we take the derivative of the volume function and set it equal to 0, we can solve it to find the point where this maximum occurs. The derivative of negative 4W cubed is negative 12W squared. And the derivative of 108W squared is 216W. With this derivative equal to 0, we can now factor out a negative 12W, and then set each factor equal to 0. When we solve, we get 0 and 18. Obviously, the width of our box cannot be 0, otherwise it would have no volume, so W equals 0 is an extraneous solution. That leaves 18 inches as the exact width we need to achieve maximum volume under postal regulations. We can find what that volume is by plugging 18 into the original volume function. This comes out to exactly 11,664 cubic inches. The length of the box can be found by plugging 18 into the length equation from earlier. That gives us 36 inches. So these are the dimensions of the largest rectangular parcel you can ship to a domestic location through the United States Postal Service. Thank you all for watching, and have a pleasant day.
Shh.